wishes to save money for his child's education, he will deposit 500 into savings account on his child's day of birth. Okay, this is immediately. Therefore, he deposits 500 at the end of each month for the next 18 years. Determine the final value for this investment if the rate of interest is 9% compounded monthly. So here we're talking about annuities. So what is annuities? Annuities, those are just number of equal payments, you know. So the formula that we're going to use, because we want to determine the final value of the investment, so we use the future. We use future value formula. It will be F is equals to X. F is equals to X into bracket 1 plus I into N the power N minus 1 over I. X is the monthly installment, N is the number of years, and I is the interest rate. Okay. Now we are told that in the immediately, so the rule here, the number of years, it will be N plus N plus 1 because of immediately and at the end. So now it will be equals to 500, it will be 500 into 1 plus 0.09 divided by 12, compounded monthly. The interest was 9%. So here on the N, you have got 18 years. You convert it to month, it will multiply by 12 plus 1 because of immediately and at the beginning, minus 1 all over by 0.09 over 12, which is equals to just use a calculator there, and then you'll get 2706 87 16 rand. Okay, so this formula here, we use it whenever we're talking about sinking funds, sinking funds and pension saving plans. Okay, let's go to number 2. Yeah, John invests 600 into account earning 8%. Okay, that's interest rate compounded quarterly. Okay, quarterly you divide by 4. His friend Peter also invests 600 rand and earn the interest compounded semi-annually, meaning every 6 months. Then that way you divide by 2. So John and Peter investment are the same. Okay, so it means the amount, is the same at the end of the 12 months, that 1 year. Calculate the interest rate of that Peter receives. Okay, now here, you can do it. This is not annuity. Okay, so here we can use the formula A is equals to A, that's amount, P into 1 plus 1 plus I to the power N. Okay, to the power N. So that's the number of years. Okay, so now we can start by calculating the amount for John. Okay, then for John, okay, let's say this is the amount for John. I'll write AG here to say that this is for John, by the way, which is also equal to the amount of peters. Okay, so now the amount that invest, okay, is 600. That's your P. Okay, then it will be 600 into 1 plus, for John it's compounded quarterly, meaning that you have got 8%, which is 0.08. It's compounded quarterly. This is 8, then divided by 4, right? Divided by 4 to the power of number of years. Okay, that one, 12 months is 1 year, so it will be compounded quarterly. Here you'll have 4, right? 1 multiplied by 4. Okay, so we can calculate the amount with the, because we're told that the amount, their investment is, they're equal. So for John, you'll get 649, right? 649, yeah, 0.46. Okay, so which is, by the way, also equal to the amount of what? To the amount of P, the amount of Peter. Yeah, all right, P here. So now using this very same formula, so it means that for Peter we know it will be the amount, now we know it will be 649.46, which is equals to 600, which is equals to 600 because they've invested the very same amount. Okay, which is into 1 plus, here we want the interest rate, it will be I. Okay, don't forget, because it's compounded semi-annual, don't forget to I divided by 2, yeah, to the power of 1. It was 1 year, so it will be to the power 2. Okay, so here you divide both sides by 600, then you will have roughly about 1 point. Here don't round, you round, or you only round on your final answer. It will be 1.08243 216. Okay, 216, which is equals to 1 plus I divided by 2. I divided by 2 to the power 2, right? So here for us, we can decide to square root both sides. We square root both sides. Okay, so we can square root both sides, and then which will boil to 1 this will boil to 1.04. Which is equals to 1 plus I divided by I divided by 2. Okay, now you take 1 to the other side, it will be 1 minus, so you're left with 0.04 there, right? So now you transfer 1 to the other side, then you'll be left with 0.04. Which is equals to I divided by 2, right? So you multiply both sides by 2, so you will have your IS 0.08 0.8 which is equals to I. So then you multiply by 100. So your I will be, then I will be 8.08%. So that's the interest rate. Okay, now let me erase and go to the next question. So number 3, the Matlango family is eager to possess their own home. They can afford a monthly payment of 4,000. They want to buy a house for 650,000, and the bank offers them a home loan at 14.3% per annum compounded monthly over a period of 20 years. Will they be able to afford the house? Okay, now here, this is your principal, so we're going to use the principal formula for annuity. Okay, so now you are given this n, the component, and then also the interest rate. So the formula that you're going to use, so note also that here we wanted the monthly installment, in other words, and then we compare it with what they can afford. Okay, so now it will be P is equals to so it will be P is equals to X into 1 minus 1 plus I to the power negative n, right, all over by I. So here, because now the bank will give the Matlangu family 650,000. So that's your P. That's what they will receive. And then another thing, note that for the loan and for the bond, bond for paying a house, know that there we use the formula we use the present value present annuity formula. Okay, so now we just substitute all the values and we solve for x here. So it will be 650. Yeah, it will be 650,000, which is equals to monthly installment, okay, into 1 minus the interest rate is 14.3%. So that's 0.143 over 12 because of compound is compounded monthly. Okay, so to the power of negative, for 20 years it will be 20 multiplied by, convert it to month, multiplied by 12. Okay, all over by should be 0. Yeah, 0.143 over 12. So here now you cross multiply this and this, right? Okay, so now you will have your x, I'll write it here. Now your x will be equal to, yeah, it will be 650,000 multiplied by 0.143 all over by 12 divided by this big square root, the square root by the square bracket, okay, all divided by square bracket 1 minus into 1 plus 0.143 divided by 12 to the power of negative 240, right? Now you can use the calculator here, then you can get which is equals to 8,224.89 rand. Okay, yes, which is greater than what they can afford, what the family can afford. So the family can afford 4,000. So no, they cannot. Yeah, so we're saying that for the loan, for the bond, we use because you are receiving money immediately. So and then there should be a gap. You start to pay after 1 month, right? So for bond, for a loan, you use the principal annuity formula. Okay, let's go to the next question. Let me erase. Mr. Brown received amount of 1 million at retirement, which he invests at a rate of 9.5 per annum, compounded monthly. This monthly expenditure, okay, this is your X, right? This monthly expenditure per month to keep up his normal way of living. For how many months will he be able to live from his investment? Okay, now this is 1 million. 1 million is this is your present value, and then this is your, because here it means that now this is the money that is receiving. So now we can use the principal formula, right? Principal annuity formula. So then this will be your X, and then we can solve for N by given so the formula that we're going to use is still the same. It will be P is equals to X into 1 minus 1 plus I to the power negative N all over by I. So we can just substitute now. Yes, it will be 1 million which is equals to monthly installment of 25,000 into 1 minus 1 plus 0.095 divided by 12 to the power negative n all over by 0.095 all over divided by. So now you can cross multiply, and then after cross multiply you divide by 25,000, and then you minus 1. Okay, yeah, note that this one here is coming from here inside the square bracket. Okay, then on the other side you'll be left with negative 1 plus 0.095 over 12 to the power n. So here you can just use a calculator, which will boil to, okay, this will be equal to negative 0.68333333. So I'll just say 3 recurring, right? Which is equals to, so here you can also use a calculator, 1 plus 0.09 inside the bracket. Yeah, it will give you negative into 1,079,16667 to the power negative n, right? So here both sides are negative, so we can divide by negative, then we get positives, right? So I can just come and I'll just erase the negatives here. Yeah, then here it will be with the rules of logs. Okay, it will be negative n is equals to log power base, of 0.683. Okay, let me write it here. It will be negative n is equals to log 1,007916667 into 0.683 recurring. Okay, which is, you can just use a calculator. This will give you minus 48.29. Okay, so again both sides are negative, you can just divide both sides by negative. So therefore our n will be 48.29 month. Yeah.